calls this standard form. But like I said, I will probably refer to this most of the time as vertex form. But this is the standard form that we're going to use as well. And the reason this is called vertex form is the h and k are your coordinates of the vertex. And so this is the form that allows you to identify what the graph looks like the most easily. Okay, the long run behavior is still going to be the same as what you saw in the general form. And that is, if A is positive, then the graph opens up. And if A is negative, then the graph opens down. Okay, the vertex is still HK. The difference is that the form itself gives you that. You don't have to calculate it. So the symmetry is still going to be a vertical line through the x-coordinate of your vertex. So it's still going to be x equals h. Your x-intercept and your y-intercepts are still going to be calculated the same way. Okay, so what you can do here, instead of using quadratic formula, you'll want to use the solve feature. And so if you took the function that they give you, set it equal to 0, so 0 equals a times x minus h squared plus k, and solve for x, that's going to give you your x-coordinate and then comma 0. This will give you all your x-intercepts. Again, there might be none of them, might be 1, might be 2. And then your y-intercept, again, calculated in the same way that you saw before. The y-intercept is the y value when x is 0. So if you let x be 0, and then if you evaluate this function, so if we take our function and evaluate it when x is 0, that's going to give us our corresponding y-coordinate. Okay, so if we took an equation that looked like this, I want you to see if you can find here really quickly what the vertex, the line of symmetry, the x and y intercepts would be for this. And see if you can find those values, please. All right, so I'm going to go ahead and talk through. Okay, as far as finding the vertex, if it's written in this vertex form, the standard form here, the vertex is simply the value of x that makes this, the expression in the parentheses equal to 0, and that would be -1. And then the y-coordinate of your vertex is this constant outside here, which is 2. Okay, so this is the easiest form to find the vertex, which is why we'll generally refer to it as the vertex form. Bless you. So symmetry, the line of symmetry is always going to be a vertical line through the x-coordinate of our vertex, so x equals -1. Okay, I'm going to solve for the x-intercept here, so I'm going to use my calculator. And once again, I can either put it into my y-editor or I can write it all out. I'm going to go ahead and enter it in my y-editor. So if I type this whole original equation, so -3 times the quantity x plus 1 squared, all plus 2. Again, double check, make sure I have it entered the way that I want it to look, and that looks fine. So what I can go ahead and do here to find my x-intercepts is I can take my y1 function, solve it for 0. So notice I've already entered it in this generic form, y1 of x equals 0, solve for x. And so if I've done that, I can use this for any of those problems. And I get my x-intercepts here. They may be radicals. Okay, when you write your radical, what you're generally going to do is write your rational part first and then the irrational part second. So when I look at these two answers here, this one's written as factors, but this one's expanded out. I'm going to write my rational part first, which is -3. And then I'm going to look at the rational or the irrational part, which is a plus √6. And then I'm going to look in that's all over 3. So this right here is one of my zeros. And now the one thing that's consistent with quadratic functions is the zeros, if you have irrational numbers, are always going to be of the form where the irrational and rational parts are the same. They're just conjugates of each other. Same terms, opposite sign between. So my other 0 is going to be -3 and √6, but the opposite sign between, a negative, over 0. Now when I look at my form here, that's what this first form actually gives us. If I distribute my negative, I get a -√6 and a -3. I'm going to write the rational part first, so -3 minus √6 all over 3. And so those would be my two zeros. And then my y-intercept, what I can do, since I've entered it in the y1 equation editor, I'm going to take y1 of 0, and I'm just going to evaluate that function. And that's going to give me what my y-intercept is. And I see that that's a -1. So I get 0, -1 for my y-intercept. The end behavior I'm going to base on the leading coefficient. My a value is a negative number, so my end behavior is it's going to open down in both directions.